So once again, the same speaker, the same clothes, the same dress, the same co-author, Michael Richter, who is sitting here. The same beginning, but this time it's a different cafe, different lab. This time it's actually in New York, where again some of the ideas of this paper were developed. And if you don't recognize Michael in the picture, here is he. Everything is the same. And also another thing that will be the same is that I will start again with some feast. This is the feast that I would like you, as a not a motivation, as a sort of to get into the mood of the paper to think about. So the situation here is, think about a community of 8 guys. As you see, they look very friendly. There is harmony in this family, not family, this group of 8 people. But there is one problem. And the one problem is that they have some accommodation complex which has 4 rooms. And here are the rooms, if you cannot imagine that. And they have to split between the 4, namely somehow the 8 has to split into the 4 rooms, namely every 2 has to live in 1 room. And the fact that they look happy means that they must be happy, namely that something is stable in the way that they are divided into the 4 rooms. Now that's called the roommate problem, and the traditional or the conventional, not traditional, the conventional solution concept or stability concept that people are used to talk about is what is called stable equilibrium. Or stability. Stability means here that there is no one agent, so there is no pair of agents that prefer to live. So of course the preferences here is about my mate. And stability here means that there is no pair of agents such that each of them prefer the other one more than his current mate. And the idea is that why it's not stable if that's the situation, because then the two would like to above their current mates and to create a new match. That's the basic idea. And that's the notion of stability that I think almost all this literature is analyzing. So let's focus for a second on a very particular case, which is this one. So there are 4 agents, not 8. Again, they have to split into 2 rooms. And the preferences here, for example, agent 1, he prefers to be with agent 2, then 3 and 4. For completeness, we also mentioned the fact that he prefers not to live with himself, namely that indeed everybody wants to live with somebody and not as a singleton. Okay, that's just to fit it into the structure that you can imagine already that we have in mind, which is the preference over the set X, where X will be 1, 2, 3, 4 in this case. Now, in this particular case, there is no stable partition. There is no stable partition. To see it, to prove it, you can see the following: 4 will be with somebody, without loss of generality will be with 1. If he is with 1, then 4 actually, as you see, 4 is in the 3rd place for all the agents 1, 2, and 3. So if 4 is with 1, 1 prefers to be with either 2 and 3 than to be with 4. And 3 finds 1 the ideal. So in this case, 3 and 1 will form a coalition or a pair that prefers each other over the current mate. So there is no stable equilibrium, and there's no stable allocation here, and it's quite well known that it's a problem that was discussed a lot in the literature, both in economics and computer sciences, conditions when it exists and does not exist, and so on. Now, this is a particular notion of stability, a very particular notion of stability, where what does it mean that something is not stable? The fact that 2 guys can get together, and together they can create something, in this case a match, which is better than the current match. We would like to propose that stability or harmony in this society that you have just seen before could have different points of view. And let me jump already in some sense to the solutions that we propose. The solution we propose in this example is that somehow, yesterday, out of the blue, the invisible end brought into the economy some set that we call the permissible set. Today, there is no permissible set. Yesterday, the set that every agent has to choose from was uniform among all the agents. Today, it will not be uniform. But it will not be uniform in a very particular way that should remind you, actually, the markets. Let me explain. Let's say, think about this. You see here the binary relation 1 above 2, above 3, above 4. The letter for this binary relation is P. It's not coincidence that it starts with the letter. The P is for, in some sense, prices. But there is no prices here. But it plays a role which is similar to the role of prices. So 1 is above 2, above 3, above 1. An agent can choose a mate, or he can consider a mate only from the mates which are lower, according to the P, from the current match. So why the red squares form equilibrium? Because, for example, 1 is with 4. He's not very happy with that. But 4 is in the end of the ladder. So he has nothing to choose from beside 4. 4 is matched with 1 and 2 with 3. These are the ideal, so it's not a problem. 3 is matched with 2. It's not the ideal. But he actually would prefer to be with Mr. 1. But the problem is that he can consider only alternatives which are lower in the rank, less expensive, you see the analogy, than the match that he is currently matched with. So if somebody, so this is not stable, a la the standard definition of stable allocation or assignment, not at all. We have seen that there is no stable assignment, but nevertheless there is some stability here because of, and now it will depend a lot about the interpretation that we will give to P. But before it, technically, it's stable because if somebody is just considering, okay, the current match, plus all the candidates, all the other agents who are lower in the ranking, then he's happy. He's not happy in a sort of a grand sense because not everybody gets his first best, not at all. But if he just considers from here down, then everything is fine. And now, of course, the question, what is the interpretation that could be given to such an equilibrium? And let us actually, at the moment, mention at least 3 interpretations. And let me already say that the 3 interpretations will fit the different contexts in different ways, and not necessarily all the interpretation will fit all the contexts and the examples that I will bring later. Interpretation number 1 is terrible. It's terrible because actually the meaning of that I am matched with John means, in some sense, that I own John. That's slavery, but it's double slavery. John also owns me. So the meaning of the equilibrium in this case is that the P is like prices. I own somebody, he owns me, and I can, in equilibrium, I can consider it's in harmony because I can just replace my partner with somebody who is cheaper than me, cheaper than him. If under this interpretation, this is an equilibrium. It does not fit this example very well, but it's one interpretation that sometimes will fit much better. Interpretation number 2 is that P is a status. P is status. 1 is more prestigious than 2, is higher status than 3, higher than 4. I match with somebody. I'm dreaming probably about being with somebody with higher status, but it's not possible. I can dream only, really, I can realize only dreams which are to replace my agent, my mate, with somebody with a lower agent, with lower status, not with higher status. So the status in this case creates actually the ladder or the personal choice sets for the individuals, such that in a way that if I can deviate only to somebody who is lower than the status of the current agent, then nobody wants to do it. notice that, interpretation 3, in some sense, is the most tricky, and probably in this case, it's probably the best. Which is, I don't know if it's the best, probably the second is the best. The third is that actually the P is not the higher the better, but actually the lower the better. The anti-P is actually the interesting, and this is connected to the word indoctrinization that I mentioned, that appears in the title. Namely, somehow people, society, somehow in equilibrium, there is some values in the world, and the values are, the P is, or anti-P is social value of what? Of living with somebody. So there is some social value that I live with a mathematician, that I share an office with a mathematician. There is probably certain people in the society that to share something with them is more valuable than others. Now, in what sense this is equilibrium? This is in harmony, because it is true that one wants actually to replace 4 with 2 and 3. But the social ladder the social value is that it's the anti-P, namely 4 is the most is the highest value. And the idea here is that when I want to make a change, I have to justify to myself. I have to justify to myself the change not only with my selfish interest, but also that I want to advance some social goal. And I'm sure that many times in your life you got to positions that you wanted to do something, but just to say you prefer to be in this room, it's not nice. But if you say that you prefer to share the room with somebody that actually needs your assistance, that's very nice. Right? And that's possible. So the P is some sort of social value that, again, technically it just determines the budget sets of the individuals. But the interpretation is, in this case, is that it is permitted to express your personal views, preferences, but only in case that you can justify it also by advancing some social goal. It's the anti-P, and notice the analogy for when you think about the standard economy, that in some sense to justify a change here, you need to do you need to suggest to consume a bundle which is cheaper. The cheaper is more valuable from economic point of view, not the more expensive, because society in some sense prefers that you will use less resources and leave more for others. Okay, it may be a little abstract. We will come to other examples soon. To those of you, I guess it's probably 2 or 3 of you are have not been yesterday or don't remember exactly, so let me just in 30 seconds just remind you the platform on which we work. We work on the notion of economy. Economy is such a model where there is a set of individuals N, there is a set of personal alternatives X. There are preferences which are preferences only of the individual alternatives. It's not on the profiles, it's not a game. And profile is a profile of alternatives, choices of the N individuals, and feasibility constraint here is a subset of the profiles that could be realized. That's the structure. And we have seen many examples yesterday, to make sure, let's take the give and take example. The give and take is everybody can choose a number between to give or to take. To take is a positive, negative is to give, and what people take from the society is to be equal to what people give to the society. So the feasibility constraint, that the sum is equal to 0. In the roommate problem, if I choose Chris has to choose me. Otherwise, it's not feasible. Okay? Equilibrium. Immediately we jump to the equilibrium definition, and the basic definition. The structure in this respect also will be close to the one yesterday. There will be 2 definitions. Yesterday it was the basic definition, and then it was the convexity. And now actually the basic is called unrestricted equilibrium, because as you can imagine, there will be restricted equilibrium in about 25 minutes. So unrestricted equilibrium, UE, what it is, look at the structure. The structure is supposed to remind you yesterday, but it's more than that. It should remind you the structure of a standard competitive equilibrium. The pair, it's a pair, xi, which is a profile of choices of the n individuals. Xi is what agent I chooses. And P, now it's not a set like yesterday. It's not the Y equilibrium. It's not the Y. But this time it is ranking. P is a ranking ordering of the X, of the set X. For xip to be equilibrium, what is needed? Two things. Number one is like yesterday, feasibility. Namely, the xi has to be in the set F. The profile has to be in the set F. Number two is the new thing relative to yesterday, but not new relative to a general equilibrium, which is xi has to be optimal, but it has to be optimal, unlike yesterday, it's not from the set X, of course, or the set Y, but this time it is from the personal budget set, and the personal budget sets are only the other choices that I can consider moving from xi, which must be only those which are inferior, at least weakly, from xi. So that's the budget set in a sense. It's not really a budget set, but this is the elements that agent I consider to choose from. Okay? So this pair, you see the prices are replaced with the P, which is ordering of xi, and the xi is the same as in competitive equilibrium. It is a pair, it's a tuple of choices. Let me again, I did not plan to repeat on that, but I do want to repeat on the interpretations with your permission. There are four basic interpretations that will play a role, and actually I said it already, but I will repeat on it. Number one, values. The P actually is ordinal relation of the prices, or namely, of the alternatives. Namely, in some sense, it's a measure, or it's not a measure, it's just an ordering of the value of the alternatives. When I am assigned to xi, I can consider only that's the value of xi in some sense, and I can replace it only with alternatives which are less valued than xi. Okay? Interpretation two is the interpretation of prestige. When I'm supposed to do xi, I'm supposed to check xi, I'm supposed to be in the club xi, I can consider I'm not allowed to dream or to think about moving to a club which has higher status. I can only move to clubs which are from a lower status. In equilibrium, I don't want to. Nobody wants to. And the anti-interpretation, the indoctrine is, I cannot pronounce this word. The indoctrine is the I word. So I am somehow brought by society to understand what is the value, the public value of doing something. And when I want to move from something that I'm supposed to do now, I consider only moving in direction that I will be also useful to the society at large. And there is a fourth interpretation, which is actually, these three interpretations are, in some sense, the centralization. Namely, somehow the P ordering appears in the world, like prices appear in the world, and things are stable. There is another interpretation, also to competitive equilibrium, of course, which is that somebody decides about the prices. In this case, there is some, let's say, some central government or central whatever, some centers that decide about the assignment of the alternatives to the different agents. Now, people are complaining. It's allowed to complain. And what could be a complaint here? a justified complaint is going to be something like, why can't I be assigned to another alternative? Not only I prefer it, but it is also in the public interest that I only move to this. And now, what is the public interest? The public interest is determined by the P relation. But again, let me say the different interpretation would fit different contexts, and it's not that in any example all the four would fit. Okay, what can we do? Again, like yesterday, we can do things. We can prove some simple propositions, and we could play with examples, and again, I will do both. Let me demonstrate a proposition again. Proposition 1 in the paper was saying the following. Give me any Pareto optimal profile, then it is a profile of unrestricted equilibrium. Give me any Pareto, we can find some P relation that will combine it into be equilibrium. How to do it? I should say one thing I forgot to mention when we talk about the feasibility. I mentioned it yesterday. We do assume here also that the feasibility set is such that it is that if there is a profile in the set F, then any permutation of it is also in the set. So permutation invariant is assumption that we made yesterday most in the cases, and we do assume it here. Okay, so give me a Pareto optimal profile, and we will find a P that together it will be equilibrium. How to do it? AI is a Pareto optimal profile. E is the set of the elements in the profile. These are the set of the alternatives that somebody, at least one person, should choose. We defined a binary relation E. X, E, Y means what? It means that, first of all, it's on the set A. It's on the set A. It means that actually it's in the NV relation. That's the reason that we notate it with E. And this means X is EY if somebody envies who are supposed to do Y, envy somebody who supposed to do X. So X now, so XEY means that there is an AI, there is an I and J, such that I is supposed to do X, J is supposed to do Y, and J prefers to do X. Now, what is the idea here? The idea here is that we would like, in this case, to prevent J from choosing X. He's supposed to do Y. We want to build a P relation such that he will not choose X. So we will need to assume, we will need to construct the P relation such that X will be above Y. In this stage, we just say that X is EY. Now, E does not have a cycle. If E would have a cycle, then because of the permutation invariance, then do the cycle and you get some Pareto improvement. So E cannot have a cycle. That's a basic property of the, which Varian and others already noted many years ago about the NV relation. In Pareto efficiency, there is no cycle. Now, if E does not have a cycle, then we can extend it to complete ordering on the set A. And now, what about the other elements? The other elements in the set X, maybe that some people want to do it, wants to take it. We want to prevent them from doing it in equilibrium. We put them in P on top. So whatever does not appear in AI, in the profile, in the Pareto optimal profile, we put on top. And then we order the relations consistently with the NV relation. This is, of course, a full ordering of the set X, and everybody is happy, quote unquote, is happy in the sense that from the alternatives that are less prestigious than the alternatives that he's supposed to take, he cannot choose something which is strictly better. So that's a basic proposition, very simple as you see, but I think we think that it has a meaning. I say that every Pareto profile is an unrestricted equilibrium profile, so it's like the second welfare theorem. The first welfare theorem is not correct. And we will see in a second example that absolutely there could be equilibria which are not Pareto efficient. Here comes an example, and the example is what we call the club economy. The club economy, the set X is a set of clubs. This will be the case that the interpretation of the P, the natural one, will be of a status. Each club has some capacity. Nx is the capacity of club X. There is a special case that we talked also yesterday about, which is the housing economy. The housing economy, of course, is the case that Nx, the club, is one house, and Nx equal to 1 for every house. But of course, that's more general. That allows clubs like in Cambridge. And now feasibility. Feasibility is assignment of the agents into the club such that no club received more than its capacity choices. Clear? Now, in this case, there are two things to say. Number one, if the sum of the nx equal to n, then indeed the existence, by the way, is not a problem here, because Pareto efficiency exists. Everything is finite here, so existence is automatically correct. But what about the first welfare theorem? So if the sum of the nx equal to n, like in the basic housing model of Shapley's curve, then indeed we will get Pareto optimality. If not, namely, of course, if the sum of nx is less than n, that's not an interesting case. There is no feasibility. But if the sum of the capacities is above n, then always there will be also a non-Pareto efficient or Pareto optimal equilibrium outcome. Let's see the proof. It's quite easy. So first of all, why it must be Pareto efficient in case 1 when the sum of nx equal to n? Because assume that xi p is equilibrium, and assumes that yi Pareto dominates xi. There must be some j who is the maximal according to the p relation for whom yj is different than xj, or yi is different than xi. So it's somebody, the most prestigious one, that actually replaces his choice in the profile y relative to the profile x. If it's Pareto dominating, it must be that yj is strictly better for him than xj. But this means also that yj must be more expensive, more prestigious than xj. But this means what? This means that there must be, since the sum of the capacities is equal to n, it means that if we move me to a higher status club, we must take out somebody from there. But if we move somebody from there, then we cannot leave him in the same place. So it must be that we moved him to another place, and therefore there is another guy who is more prestigious than me that actually changes in the profile y is club, and that's of course impossible. Conclusion: in the case that the sum of nx is equal to n, then we have the first welfare theorem does hold. The other case it's not. And I think it's fun to see the proof. So I want now to show that there is an equilibrium which is not Pareto efficient. I start actually with xi, which is Pareto efficient. And because of the previous proposition, I know that we can construct a P such that xip will be equilibrium, correct? That's we just seen before. But now, since there is a surplus of capacity, then there must be some club which has a surplus of capacity relative, there is an excess of capacity according to the profile xi, right? Because the sum is above, so there must be there are some empty slots somewhere. And there must be somebody who is not going to this club. What we are going to do, we are going to take this guy, to move him to this club, and to change the profile, the P, in a way that we will take the P to the bottom of the public relation. Now, in this way, what we do is, since nobody wanted actually to move to this club, because if they could move and they prefer the current, then they will stay in the club that they are in according to the profile Xi. But now, this guy, we moved him to something which is worse for him, but nevertheless, he cannot move because we moved actually the quality, the status of this club to the bottom. So we got something which is Pareto inferior because we moved him to a worse club, and nevertheless, we can support it as equilibrium according to this definition. That's the type of results and examples that we can play with. Let me skip on that, and let me just say, without the proof, that up to now, actually, one problem with whatever we were talking about is that the peer relation was completely free. It was completely we don't have any discipline about the choice. It could be completely arbitrary. And often it does not make much sense. And let me say, just quote a proposition, that if the preferences are monotonic, namely there is some sort of basic partial ordering such that whenever A are B, then the preference prefer A to B, like monotonicity in the standard exchange economy, then indeed we can find the peer relation, the equilibrium relation, to be also such that it will be also obey the R monotonicity, so it will not be completely arbitrary. Now, when we presented this work a few years ago, then some of the criticisms that we had on this concept up to now was, you are talking about something like a second welfare theorem, and but what about initial endowment? Well, now, several things I would like to say in this stage. Number one, notice a very important property of competitive equilibrium. Competitive equilibrium is the property. You have a trade, you start from initial endowment. You have a trade in competitive equilibrium, you go to sleep. The next morning, you're awake, and you are asking yourself, can be a new trade? And the answer, no, because actually the prices that brought you from the initial endowment to whatever are such that they support that if you open the trade again, you're stuck, you stay in the same thing, in the same point. So actually, when we think about trade and about equilibrium and exchange, there are actually two stages, and we would like, Michael and me, we would like actually to separate between the two. There is one question, which is whether something is stable in the sense, like the outcome of competitive equilibrium. It's stable in the sense that there is no reason to open the trade again, given the prices and given the whatever the outcome of the trade in the competitive equilibrium. And there is a second stage, or first stage actually, or zero stage, which is how to come to this point. And of course, the idea of the standard competitive equilibrium is that the initial conditions, the initial endowment determines, with the prices, determines the outcome of the trade. But in principle, you can think about the second stage and separate it from the move from the initial endowment to this stage. So I don't think that it's necessary to include in such a model initial endowment, but nevertheless, actually, in a new version of the story, by the way, since it's a Marshall lecture, I found actually a quotation that about Marshall that says, it's not a serious justification, but that in any case, let's read it. In the passages dedicated to market prices and to very short period analysis, the indications concerning the agent's utility functions and the initial endowments are either lacking, incomplete, or appear in his Appendix F. That's okay. So now we have authority. We do like Marshall, more or less. But we could add the initial endowment to the story here, but the interpretation should be quite, it's not as simple or not as straightforward as in the exchange. In the exchange model, the initial endowment means I own something. And unless I trade, I can continue, hold, and consume whatever I start the trade with, right? Now, but we are talking about environments, about economies where actually there is no trade in this sense, and it's much more abstract, and the alternatives are not just consuming something, right? So therefore, it's not a matter necessarily of ownership. So what's the meaning then of initial endowment? Initial ownership, so the initial profile, the interpretation that we would give is that sometimes society gives rights to people to do something independently of what happens. So initial endowment in this respect would be, it's the right of somebody to do something, and it's given to him by some tradition, by law, by whatever. This is what we call extended economy, and we don't have time to talk about it, but let me just bring the definition. So we can extend the idea of unrestricted equilibrium with this endowment, but this time actually the optimality of xi will not be relative to xi, but it will be related to ei. Namely, the budget set of each individual. There is a P, and the equilibrium is xi, a profile, and P, such that xi is optimal, but now it's xi has to be optimal relative to all the alternatives which are less prestigious than ei. So talking about prestige, actually ei is actually the source of the prestige that I have, and I can choose alternative which is lower prestige than the one that I am born with, the social sect that I'm belonging to, or whatever, or under the other interpretation, I can just move from EI only to actions or alternatives which are more socially valuable than the one which I am assigned or was born to choose. But let me skip on this. There are many things to say about it, and let me move to another subject that is very dear to us, and that will lead us to the last concept, to the twist that we will do with the equilibrium concept, and this will be also the end of the lecture. So, but the next 10 minutes, we would like actually to talk about a notion of what we call convex preferences. It's something that we developed in a paper in AR a few years ago, and then in another paper in theoretical economics. And here actually we are going to present one of the variations for the convex preferences that we have in mind. Now, the idea of convex preferences is to expand the idea of the convexity that is so central in economics to also spaces or worlds where the standard convexity notion of preferences does not apply. And in a second, you will understand what I mean. Think about the following situation. You have some teacher, professor that you have to replace, you want to replace, or you have to replace, or you consider to replace. There are two guys here. The guy on the left is a good teacher. The quotation here is again from Marshall, and that's the way that he describes more or less a good teacher. So he calls for vitality and initiative on the part of the educator and so on. That's okay. He's a good teacher. He's a good teacher is not necessarily such a good researcher. Now, when you consider in life replacing him, and there are many candidates, I think that often is the case that you say to yourself, okay, he's a good educator, but actually he's not a good teacher. He's a good teacher, but he's not a good researcher. So what is the critical factor that we are having in mind when we consider somebody to be better than him? He should be a better researcher. So the quality of the research is the critical criterion. If somebody is better in terms of the education as a teacher is not so important, but what is important is that it will be better as a researcher. It's not necessarily that I will prefer him, but if he's not better than a researcher, he's gone. And the opposite, the other direction. If you have a teacher who is very bad, like the description of Marshall of a bad teacher on the right, then even if he's a good researcher, when you think about replacement, you don't think about his research, you think about somebody who will better on the education. So this is just to illustrate the idea that often in real life, when we consider changing from something, we have what we call a critical consideration. a critical consideration that a necessary, not sufficient condition for moving, for improving from what we have in mind, what we do now, is to improve on this direction. Believe it or not, but this is very strongly related to the standard concept of convexity that you are using every day. And here is the model that we have in mind. You have a set X, and now the critical addition that we have to the model, there is a set of primitive orderings. In the examples that I just gave you, is the primitive orderings is being better according to his research, being better according to education, being better according to his height, or whatever considerations we want to have in mind. Now, what does it mean, lambda convex? Lambda convex, the convexity now depends, you see, it's nothing to do now with Euclidean spaces or standard convexity notion. What is lambda convex? Lambda convex is, preference is called lambda convex if for every B, for every alternative, there is some critical consideration, denoted by greater or equal K, such that it's necessary for B better than B, that you are better according to this criterion. Okay? So you see, that's a definition which is not using the standard convexity concept, but you can see, and we will see in a second, that actually it is in the case of Euclidean spaces, it will be exactly the same. What do you mean exactly the same? I will explain in a second. So why do we like so much this alternative definition? Number one, because I think it's compelling as a description of a procedure of choice. And my personal and also Michael's view about these models is that I would like the models to describe some procedure of choice and not, or to be connected with reasonable procedure of choice. At least we think that this is a merit of a model if it does. Number two, it does not require algebraic structure. The standard convexity notion requires that you talk about A and B, something between. Something between is determined by some algebraic structure that you can say that C is between A and B. Here, there is nothing like that. As you will see in a second, it generalizes standard convexity notion of Euclidean spaces, and it also emphasizes the dependence of the property of convexity on what are the set lambda. Namely, what is the set of the considerations that play a role in the reasoning or deliberation of the agents. Just very brief two examples. Number one, let's say that the set X is interval on the reals. And let's say that the set lambda containing only two considerations, either going up or going down. So the two considerations that you can use are only it's above or it's below. That's all. In this case, lambda convexity would be the same as single peakedness. Look at the picture on the left. What you see is that this is a single peak. In this case, this point, there is of course the critical direction is going up. Sorry, going to the left, right? It's going to the left, down actually. So actually, to be better than this point, you must actually go to the left. To be better than this point, you must go to the right. Not necessarily everything that goes to the right is better, but a critical thing is that you go to the right. And this point actually, formally both directions are critical because actually in necessary condition, you cannot go up. So it's fine. This, on the other hand, is something like that is not a lambda convex with this lambda because, of course, to go up, you can go both to the left and both to the right. So there is no one necessary consideration to improve upon this point. It's easy to see that actually the being strictly convex here is exactly like being single-peaked. It's also very easy to see that in the Euclidean space, if the set X is a convex, let's say, closed subset of Rn, then define what we call algebraic linear ordering. Algebraic linear ordering is an ordering which is there is some vector v different than 0, such that x is better vy if you multiply the product of vx is greater or equal to the product of vy. Let me whisper that this is actually algebraic linear orderings. Of course, this is what plays so much important role in standard economics, because if V is the price, then this means actually the expense. And it's more V is greater or equal price Y if it's more expensive than Y. Now, if C is the set of all algebraic linear orderings, then we can easily show that if you have a preference, at least continuous preference, on the set X, then being convexity in the standard definition is exactly a parallel to psi convexity. And you can easily see why, because if you have a standard if you have a standard convexity, then it means that the set, for every B, the set of the upper contour has to be a convex set. But if it's convex sets, then there is a separating argument here, right? So in the separating hyperplane actually determine such a V, and that's all. And it's easy to see also the adverse direction, that if you have a psi convexity according to this definition, then it implies preference, that preferences are convex in the standard convexity definition. So, as I said, I don't know if you're excited about it or not. Michael and me are, because it's convexity without algebra. Convexity without algebra, and it does have, I think, a very natural interpretation as a sort of a process of reasoning about formation of preferences. Let me skip on that because of time, and let me go to the final point of this lecture, which is, again, I promised you to do some twist in the equilibrium definition, and that's what we are going to do now. As I said before, up to now, in unrestricted equilibrium, the P could be everything. But now we are going to restrict it. It will not be unrestricted. We call it, because of some reason, primitive equilibrium, probably because we love the letter P. And now take a convex economy, namely we add to the structure also that the set lambda of orderings on the set X, and we require that all preferences are lambda convex. Preferences are lambda convex, like we assume in standard exchange economies that the preferences are convex. And primitive equilibrium is just a regular unrestricted equilibrium, but there is one additional requirement. The P is not arbitrary. The P has to be also one of the alternatives, one of the orderings in the set lambda. Now, again, I would like you to see the connection between this and standard competitive equilibrium. Competitive equilibrium rely on convexity. Convexity in the standard sense. Convexity in the standard sense means, in our notation, on our concept, lambda convexity, where the set of lambda are the algebraic linear orderings. What is competitive equilibrium? Competitive equilibrium is actually like an ordering. It's like a primitive ordering where the ordering is, the prices are determined, the more expensive relation is a algebraic linear ordering. So you have this connection in the standard competitive equilibrium between the notion of convexity and the notion of equilibrium, and it's not, of course, a miracle, and it's not by coincidence that we require linear prices. Without linear prices, everything that we say, or almost everything that we say about equilibrium will collapse. So it's a relation between the convexity and the fact that we ask for linear prices that bring us all the results. I will finish with two examples. So that's the notion now. The primitive, it cannot be just an ordering. It must be an ordering from the set lambda. Let me also mention that we take the lambda also in some sense as to think about this as a language. It's the language by which you can express, in this case, let's say, what does it mean more prestigious? To be more prestigious is to know more mathematics, to be higher. whatever, right? So it must be one of the alternatives. It must be one of the basic orderings that we use in the language that we also can construct the preferences. So take, for example, this story again, the give and take, just to remind you, plus is to take, minus is negative, and assume the feasibility is the sum of the choices has to be equal to 0. What people give has to be equal to what people take. And the lambda in this case is like before, it's up and down, increasing and decreasing. And as I've said, the convexity means here that there is strict convexity means here that there is a single pickedness. And now, of course, again, take the case, if the sum of the peaks is equal to 0, then there is, of course, a trivial equilibrium, which is the p is indifference, right? Everybody can choose whatever, and choose this peak. Now, but if the sum of the peaks is positive, like the case that we talked about yesterday, then that's not the case. And here it's very easy to see that actually there are two candidates to the p here, the increasing and decreasing. And of course, if the sum of the peaks is positive, the equilibrium will be the only equilibrium will be with increasing. Why? Because if it is with decreasing, then everybody will choose. If it's with decreasing, then in xi it cannot be that I will be to the left of the peak, because if I'm supposed to be the left of the peak, I can go down. I can go down and choose the peak. So therefore, it must be that the equilibrium must be with the preference of increasing, which actually the expression or the meaning of it is that I'm allowed to deviate, but by only whatever I'm assigned to do, I'm allowed to deviate from it only by taking less or giving more, which makes very much sense. If the situation is that people want actually to take more than to give, then actually the constraint of the status should be that, or in this case, actually, the interpretation here probably will be, the best interpretation will be in the I word, namely, the more it's more socially valuable to take less than what you are supposed to take, or to give more, not the opposite. So, and regarding the profiles, actually, every profile which is feasible, such that every choice of individual will be to the left of his peak, will be equilibrium with this, with the increasing preference. We have only 5 minutes, so let me skip on that and move to just to welfare theorems. And it's too little time to talk about it too much, but let it just is express just to say the following. The primitive, why we're interested, first of all, in welfare theorems here in this context? Because first of all, we're interested in welfare theorems, and second, from methodological or deductive, from educational point of view, we are interested actually to understand what is special about the models, the standard models that we play with economics, that we could get the first and second world theorem. And as you already have seen, it's not true in general. So so it's not true in general that the P equilibrium will be Pareto efficient, but there is one condition that apparently is a very simple condition. It's not a big discovery, but at least for us it was quite interesting to see that this is actually a necessary and sufficient condition on economy to have the first welfare theorem. And the condition is related again, of course, to the set lambda. It's related to the set lambda, namely it's related to the orderings that are permitted to bring harmony into the society. And the condition D is the following. It will be very familiar to you. A convex environment or economy satisfies condition D if there are no two distinct profiles, feasible profiles, AI and BI, and some preference K, some ordering K, namely one of the ordering, the primitive ordering, such that the B is weakly Pareto dominating A. Now, this is exactly a condition that is satisfied by what? By the expense function, by the relation of more expensive. You don't have two feasible allocations of the endowment such that the total endowment such that it's more for every I, the bundle that you get according to B is more expensive than in the profile A, right? We use it all the time, this property. So it's true there, and this is apparently the sufficient and necessary condition for the first welfare theorem. So give me a convex environment. Again, notice the convex environment does add also, we have also the lambda. By environment, we don't have the preferences, but it's not important at the moment. We have the lambda. And now give me such a convex environment. If the convex environment sets as condition D, then whatever are the preferences, then the PE, the primitive equilibrium, must be, or the PE outcome must be at least weakly Pareto optimal. Why that? Because if you have equilibrium like that, and if you have another profile which is BI such that for every I, it's either BI better than I for I, or BI equal to AI, then it must be, and if you have the preference case or ordering K is the P relation that support it, then it must be, if I prefer BI to AI, it must be that he cannot afford it. Cannot afford it means that BI is, according to greater K, strictly better than AI. But we have the condition D just says that there is no such a primitive ordering such that this configuration is possible. And we don't have time for that, but it's quite easy to see that actually the opposite is also correct. Namely, if D fails, then we can find such a profile of preferences. Actually, it's very easy. The people just adopt these primitive orderings as preferences such that there will be equilibrium, and this will be the dominated profile, will be equilibrium, although it's not Pareto optimal. In the paper, if you are interested, you will find some similar analysis regarding the second welfare theorem. Namely, we identify conditions that is sufficient and it's almost necessary for the second welfare theorem to exist. And basically, this is what you see here in the picture. What you see in the picture is this property that if, according to these primitive orderings, A is the best. According to this primitive ordering, A prime is the best, is optimal form in the budget set. Then there is some pair, B prime, which Pareto dominates A and prime, and in some sense feasible. So this is basically the property that is obvious when we teach pi theory. It's not obvious when we think about the examples in our abstract model, but this is basically the sufficient and necessary condition for the second welfare theorem to exist. So what we get from there, we get some sort of proposition that allow us in examples, and in the paper you will see many examples, to derive a first and second welfare theorem, but probably more important is a sort of pedagogical point, which is just to understand that this miracle that we have about the first and second welfare theorem that we teach and preach and so on, is connected actually with the very special structure that we have and the connection between the primitive orderings that creates the convexity concept and the fact that the prices has to be, or the more expensive ordering has to be linear, and the parallel is clear. I will skip on this speech. You have heard it yesterday, so thank you very much.
I have a question which also applies both to today's lecture as well as yesterday's lecture, right? So when you say that we have these sort of norms that tell people what is feasible, what is not feasible, right? How do you imagine these norms may appear in real life? So, what would motivate people perhaps to maybe bargain or somehow move to those norms?
Okay, so in some cases, like yesterday, actually in the paper, we do talk about some sort of dynamical process that more or less may explain the evolution of what we call yesterday the Y equilibrium. In this paper, actually, we did not include dynamics. But in any case, even for the paper yesterday, I don't think we take it too seriously. I think that it's the dynamics that leads to equilibrium. I think it's problematic, to my experience, when we talk about natural equilibrium, when we talk about competitive equilibrium. I'm not saying that that's not an excuse. And I'm not saying that it's not an interesting question, but I have just to say that we have very little to say about it. The approach that we take here in the two papers, in all the papers that in this project, is a pure equilibrium. We are not specifying how the equilibrium is achieved, how it's obtained. Sometimes we have some stories that you can or cannot be persuaded with, but we are absolutely not arguing for that. We can say that it's for future research. We can say that it's not for future research. Let me also say that you remember that there was a fourth interpretation to what I was speaking today, which was that actually, and that's actually interpretation that it's true about natural equilibrium, it's interpretation which is true about competitive equilibrium, which is that actually the equilibrium is determined by somebody. Some authority determines the equilibrium. And of course, in this case, if there is authority like that, and this is obvious how it comes, because they decide. Now, why do they decide? In this case, the idea would be that what they care about, the authority, is just harmony. They don't care what will be the exact division of the 8 guys into the 4 rooms. They don't care at all. They just want to have silence in the community. That there will be harmony. People will not argue. No war. No collapse. Things will not. And I think that's quite true about many situations in life. That actually the authority, whether the authority is the parents, or whether the authority is the teacher, or whether the authority is the government, actually, at least in many contexts, we care about achieving, somehow organize the society in a harmonic way, and not necessarily about the content of the outcome. We want people to have consensus, but we don't care so much. We want a consensus about what restaurants to go tonight, but we don't care actually whether the consensus will be in restaurant A, B, or C. We want the party to have some position which is uniform, and at least in some range. We don't care so much about what is the exact position that is taken, and things like that. Here, the allocation of resources. The authority wants quiet, political quiet, that people will take whatever they take and not complain about and so on.
In this setup, is it fair to say there's first mover advantage? If I grab power, I set the thing, then it will be the equilibrium. Then we just go with that. If somebody else grab the power, he sets another equilibrium, everyone will just go with that one then. So better if I do it than somebody else.
I'm not sure. You talk about the last interpretation, the authority interpretation?
Yeah.
Well, if there are two authorities, I guess they fight. If there is a mother and father, I've seen some fights between mothers and fathers about education of children in my life. So if there are two governments and two leaders, then often there is a fight. We don't know about that. I mean, the interpretation of this concept would not fit to such situation. It would fit only to situations there is one authority that can determine. This is in the centralized interpretation. But let me emphasize again, the main interpretation that we give here is decentralized, although we don't have a good answer to this question about the dynamics, but we do think about it as some sort of concept, in this case status or social values, social preferences that are determined in the society in a ways that bring harmony, like prices, analogous to the ways that prices bring harmony in an exchange economy.
So my question relates to creating the social order, or the P, to support a given allocation. So the proof that you went through in the middle of the presentation was about finding a P to support a Pareto optimal allocation. Say if I were a government who wants to find a way to create an allocation that benefits me as the leader, but perhaps is not Pareto optimal, can I find a P or a social order which supports this extractive allocation?
Well, sometimes yes, sometimes not. We don't have a general proposition for that. You cannot, it's not absolutely not true that you can support everything, because we have many examples where actually the equilibrium must be Pareto efficient, as we have seen. Now, if you're a leader, also notice that, again, when you think about a leader or authorities, I don't think they are free to determine any P. And in the proposition in the beginning, in the unrestricted equilibrium, we were completely free to choose the P. Given that there are constraints also about the orders that you can, or the ways that you indoctrinize the citizens, then you have constraints, and that brings you to the primitive orderings. And then with convexity, again, you get that you can obtain only Pareto efficient. So sometimes yes, sometimes not. It depends, and depends on your tools whether you can achieve. It's not true, as I said. We've seen some examples that, like in the club's case, that absolutely there could be equilibria which are not Pareto efficient.
Well, in that case, if we extend the concerns of whatever the authority is, and more generally, whatever the determinant of P is, from achieving harmony to achieving any other objective, doesn't that turn into a game?
Look, a game between whom and whom?
Well, if there is an objective other than harmony, it seems that the authority is trying to attain something, and if I was living in that environment, I would try to take that into account when deciding whatever the choice I made. So it seems to me that there are strategic incentives there.
Well, I'm not sure, because here actually, in most of the cases, the relevant cases we will play with, once you determine the P, you determine the outcome. So, and the outcome, the agents in this case, once you determine the P, and you assign, let's say, you assign the profile, then there is no game. The only thing that you have to do is to ask yourself whether you want to deviate from the order that you got. So there's no game. The reasoning of the player, there is no strategic reasoning here. That's very important, because actually the only thing, it's like is exchange economy a game? Is exchange economy a game? I don't think so, because the only what you have to do is that you are assigned to let's say, with initial endowment, you have some budget set, and independently of what the other players, the agents do, you do your maximization. You don't think strategically about what other people do.
Does that depend on how many other people do?
Sorry?
Does that not depend on how many other people?
No, not at all. Not given that the prices are given. That's the idea of competitive equilibrium, right? If you determine the prices and you're one of the agents who determine the prices, then it starts to be a consideration, but not in this way. So it's not a game at all.
Thank you. So please correct me if I'm wrong at any point, but the way I interpret it is that you are essentially getting around Araprat's impossibility by essentially...
no. Let me stop you already. No. Eros impossibility... No.
But I mean, you are deriving a social preference order in a way. Isn't that the P ordering in some sense?
No. The social order, no. Okay, thanks for the question, because it will clarify something. The alternatives here are individual alternatives. In error, in social choice, the alternatives are community. It's not that you can choose something and I can choose something else. Society chooses one thing, right? Here, the social ordering, probably the word social ordering probably is misleading or confusing. The social ordering here, let's call it status. The status is of the alternatives that you choose, the clubs that you choose. It's over the clubs. It's not over, in error would be, or the social choice problem would be, it will be to determine you have preferences over the assignment of, let's say, the agents to the clubs. People have different preferences over the assignments. And then somehow you aggregate it into one assignment. That's not the structure here at all. The social ordering is on the set X, is the set of the individual alternatives. It's not on the set of the preference.
Sure, but if you interpret P as prestige, for example, can you not interpret it as...
No, because the prestige, but let's be formal for a second. The prestige is again about X, is the individuals. We don't choose, the outcome is not a preference relation. It's okay, I think that I now understand what you have in mind. What you have in mind is that you take X, so I should probably say no, yes, or something like that. Okay, let me think about it again. So you can think about, you are right, that you can think about it, that you have here a preference relation over the set X, which is a function of the n of the profile of preferences plus the feasibility constraint.
And that's just a domain restriction, isn't it?
That's the main restriction.
Yeah. So, and I get that in settings like, for example, a couple of friends go to a camp and it's about the room allocation and we all randomly pull a name out of a hat, and then we start trading to see who ends up in which room with anybody else.
Right, but But the interpretation, we thought about it once, but it's a good question. Sorry, it's not. First of all, it's not a matter of getting around the Eros impossibility theorem. That's for another lecture. I don't think that's it's not around. There is a structure, you are right, that given that we fix the F, and given the fix the F, then you can think about it as a source of a social welfare function about the set X. But there is no reason indeed. I don't see any reason here that the IAA will be satisfied here, and it's not. And what else? I don't have to think more about it. But the interpretation here is, notice that again, the interpretation is extremely different. It's so that technically it's a function from a profile of preference into a preference. We have to think more about it. I don't want to answer on the spot. But notice, it's true that formally there is some relation, but the interpretation is completely different. because again, the choices is, usually when you think about preferences, you think about the preference in the social welfare function. These are public actions, or it could be allocations. But the allocations here is the outcome of, in some sense, the outcome of the process is, but the preference here is not, again, the preference, the outcome of the process here is a preference over the X, and it's not a preference over the preference. See, in the social welfare function, it should be a social, it should be preference over the preference, and that's not the case here. But you are right, and that's, it's a point that we thought about, but somehow we dismissed, so. But it's not, I would not agree with you that it's not a way to get around the welfare perspective.
All right, my actual question was going to be regarding whether you see any mechanism. So for example, if we go to the campfire and we pull the initial names out of the hats, that's a mechanism to essentially end up in a feasibility constraint like you impose. But would something like that also be generalizable to, I don't know, voting, for instance?
I don't know. We don't.
Have you thought?
It's a good question. No, we did not think about it, but that's a good question. It's a good direction of research, which is to implementation in some sense that will bring to this, like in any other concept, that will bring to this concept.
So thank you for the really interesting talks both yesterday and today. So my question is mostly about what you covered yesterday, and going back to the concept of the framework of what's permissible or not. And it's still a question of trying to see whether you can, I guess, bring back a bit of game theory, but actually applying that framework to game theory. And the idea is that you started with the example of the cake and the family dinner. And if I want to build up on that example, often after a family dinner, you play, for example, a game like with your family members. And that's usually a situation in which, obviously, you want to try to be strategic and to win, but it's actually not permissible to be too smart or to try to be the one that kind of ruins the game by winning everything at Monopoly or whatever you are playing. And so the idea is that then you could apply these restrictions in terms of what permissible, in terms of how smart you can be in certain situations, in terms of your strategic thinking. And so it's a vague idea, but maybe there's a way to applying this to then limit how strategic you can be in certain situations, and that allows you to, for example, select more among equilibria in the same way that we do it in some models, by not saying that being too smart is not permissible, but by saying okay, some people are not smart enough, and then there's a distribution of people, some of which are smarter and not smarter, and that can tell us something about some games.
I cannot see directly how it can be done. It's again, I think it is very fundamentally what we were talking both yesterday and today, and also some other papers that are connected to this project. What resolved there is something very simple that resolves the situation. The very simple thing yesterday was the set of the permissible set, and today this is the P relation. And this somehow brings harmony into the society in different mechanisms. Now, maybe that it could, in particular games, I can imagine that there are maybe something which is in this very vague direction. It's not a matter of more being smart or less smart, but the behavior could be explained as an outcome of some working or deciding, make decisions according to some, taking into account another factor. So here, under interpretation of the prestige, this is resolved in a sense by actually, in some sense, we change the preferences in a uniform way. We change the preferences or the consideration of the agents. You don't want to move. You want to deviate to an alternative which is less socially valued or something like that. And now there is some norm of behavior or something that is actually would be the interpretation of equilibrium. I don't know. I cannot give you a good answer more than that. It's very different. By the way, of course, although we call it no games, I'm not against games. Do games. It's a different type of story. It's a different type of reasoning, and I think very fundamentally it's very different because here we don't think about other people. We just make our decision independently and taking into account selfish or non-selfish considerations, and things are in harmony. And strategic reasoning, serious strategic reasoning, is about me thinking, putting myself into the shoes of the other, and that's absolutely not part of the competitive equilibrium idea or the general equilibrium idea. In this respect, what we do here is much closer to general equilibrium than to game theory. Although, again, some of the situations here could be analyzed also as games. We are not denying it. But it will be very particular sort of games, because if I care only about my action, not about your action, then the only consideration of that I care about your action only because of the feasibility. And that's what I was talking yesterday about, and that's connected with the concept of social equilibrium of Debray. So this will, the type of games that probably would fit what we were talking yesterday about would be very, very particular set of games.
We're almost out of time, so I'll take a very short answer if that's what it takes. We do have a story, which I don't particularly like, that we tell students about Nash equilibrium and how it comes about. I want to go back to that thing. I don't like it because basically it invokes common knowledge of everything and their grandmother, and it's not very convincing. It's just restating that this is a very difficult thing. It's not really a story. Still, the question is, have you thought about, this is the epistemic so-called, have you thought about, we can ask the question really in the case of yesterday or of today, whether the epistemic conditions are more stringent or not. It sounds like they're less stringent here, but maybe for the simple reason that these are individual preferences rather than... have you thought about this at all? That's the question. You can just say, no, I haven't thought about it.
Did we think about it, Michael?
No.
No. So you have double no. No, I don't... Do you know about epistemologic discussion of competitive equilibrium?
No.
So this we...
But I certainly use some of that when I teach Nash equilibrium, only to tell them we don't really have a story, but we have these equivalent conditions.
Well, if the epistemological story here would be much more involved than Nash equilibrium, because it would have to include statement of the type. The language that we will use is about what is permissible or not. So the structure of the propositions, I think, would have to be very, very different. I don't know. I am just, since you mentioned this speculation, I just speculate that if there is anything like that, it would be quite complicated. But the spirit of it is, in a sense, you can say that the set of permissible is common knowledge, but it's...
It sounds like if you allow that statement as a primitive, then everything should be relatively simple. But you're saying that you...
Well, yeah, if you want, you can say that you ask yourself, if the permissible has to be common knowledge and the outcome is feasible, then that's exactly the definition. And something similar will be, you can say about today's talk. But again, let me just summarize. The idea here was the joint to the two papers is to include another factor that somehow affects the decisions of the individuals, which is uniform for everybody, and somehow, surprise, like prices, bring harmony. So these were two different items formally, and with many interpretations today, less interpretation yesterday. But in principle, one can think, and we thought about other ideas of this type, and that's actually the message of these two lectures. Economics, no question that these are economic questions, but going and trying to find ideas or ways, not in practical sense, but a sort of philosophical sense, that somehow resolve and bring harmony in these conflicting situations. That's the idea.